Hello friends, let's start the assignment 2. The example 1. Prove that 100110111. This is a basis for R3, 3 dimension. So the proof is, for the basis again we have to solve that these 3 vectors are linearly independent, and secondly we have to show that all these vectors are the generators for R3, right? These two conditions we have to prove always to show that these are the basis for R3. Alright, the first is I'm going to show that these vectors are linearly independent. For that, I have taken the linear combinations of all these vectors. So I get alpha 100 plus beta 110 plus gamma 110 equal to 0, 0, 0. So this is a linear combinations, and I have taken my scalars to be alpha, beta, gamma. Alright, let's solve this. So I just directly adding all this. So from here I get alpha, from here I get beta, from here I'm getting gamma. So this is alpha plus beta plus gamma, and then the second coordinate, this is 0, this is beta, and this is gamma. So 0 plus beta plus gamma is beta plus gamma, and then it is 0 plus gamma, I get gamma. So this is equal to 0, 0, 0. From here I get sum of alpha plus beta plus gamma to be equal to 0, and sum of beta plus gamma is also 0, and here gamma is equal to 0. Now either you can solve alpha, beta, gamma separately by adjusting the equations and solving these 3, get the values of alpha, beta, gamma. The other method is just take the coefficient matrix of this system of equations. So just write the coefficients of the scalars, and I get 1, 0, 0, and then I'm having 1, 1, 0, and at the last column I have 1, 1, 1. And take the determinant, and if you solve this you get your determinant to be equal to 1, which is not 0. And whenever you're having determinant to be non-zero, which means the system 1 has a trivial solution, and for a trivial solution all the scalars are always 0. So the system has only trivial solution because I got my determinant to be non-zero, and trivial solution means all these scalars are 0, which means these vectors are linearly independent. This is the shortest method. You can also solve these equations to get the values of alpha, beta, gamma, but this is another method. And the second thing is I have to prove that these 3 vectors generates R3. For that I have to take one element from R3 first. Any element, any vector. So I am taking the vector to be x, y, z from this R3. And x, y, z, I have to prove that every element of R3 is a linear combination of these vectors, right? So I have taken x, y, z to be the linear combinations of these vectors. Let's say alpha times the scalars to be alpha, beta, gamma, let's say. So this is 1, 0, 0, beta 1, 1, 0, and gamma 1, 1, 1. So this is equal to, just add them. From here I get alpha plus beta plus gamma as the first coordinate, and then this is 0 plus beta plus gamma the second, and then this is 0, this is 0, this is gamma, right? Now just mark this as star, and I get 3 equations. Then I get x to be equal to alpha plus beta plus gamma, and then y is equal to beta plus gamma, and z is equal to gamma. What my task is, I have to get the values of alpha, beta, gamma from these equations. just get the value of alpha, beta, gamma and place these values in star. Then you say that this vector is a linear combination of 1 0 0, 1 1 0, 1 1 1, the given vectors. And then you say that these forms the basis for R3. Right? So I have to get the values of alpha, beta, gamma in terms of x, y, z. Then only I can say that x, y, z is the linear combinations of all these. Because so far in the previous examples, how we are getting in assignment 1, we have always written x, y, z to be the linear combinations of this, where we have this in the form of x, y, z. This should be, whenever you write the linear combinations of these vectors, this should be in the form of x, y, z. But here in this example, I'm having alpha, beta, gamma. So I need my alpha, beta, gamma to be in terms of x, y, z. Then only I can say that x, y, z is a linear combinations of 1 0 0, 1 1 0 and 1 1 1. I hope it's clear to you. Alright, so now let's solve these three equations and get the values of alpha, beta, gamma in terms of x, y, z. And you will see here that already gamma is z. Right? Okay, so let me mark this as 2, this as 3, this as 4. Right? If you subtract 3 from 4 and 4 from 3, you will get, you can choose any of the methods you want, any of the subtractions or additions of the equations you want. It's your choice. Just get the values of alpha, beta, gamma, right? Here I have written the formula, the format, how I have get the values of alpha, beta, gamma. So I've already written that. I have subtracted 3 from 4 and 4 from 3 to get alpha, beta, gamma, and I got my alpha to be as x minus y and beta as y minus z and gamma is z. It is already known to us that gamma is z. So now substituting this alpha, beta, gamma in the star, right? So let me substitute this value, x minus y 1 0 0 plus y minus z 1 1 0 and gamma is z 1 1 1. So finally x, y, z is a linear combinations of these vectors, but x, y, z was arbitrary. Therefore every element of R3 is a linear combinations of the given vectors, which means all these vectors forms the basis for R3. Alright, let's do one more example. Prove that these vectors forms the basis for R3. For that, the two conditions. First one is I have to show that these vectors are linearly independent, and then I have to show that these vectors are generators of R3, or these vectors are every element of R3 is a linear combinations of all these vectors, right? Okay, now the first condition, to show that these are linearly independent. For that, let me take the linear combinations of these vectors. So let alpha 1 2 1 plus beta 2 1 0 plus gamma 1 minus 1 2. So this is equal to 0 0 0. Fine. So let me add these vectors. Here I get alpha plus 2 beta plus gamma. So alpha plus 2 beta plus gamma, and then 2 alpha plus beta minus gamma, and then alpha, beta is 0. If you multiply beta with 0, you get 0, and here it is plus 2 gamma. So this is equal to 0 0 0. So now I get three equations, that is alpha plus 2 beta plus gamma equal to 0, and then 2 alpha plus beta minus gamma is equal to 0, and third one is alpha plus 2 gamma is equal to 0. You can either solve the values for alpha, beta, gamma from these three equations, or you can use another method. So I always try to use this method to solve the determinant of the coefficient matrix, which is the easier one. So mark this as 1. So let A is equal to the coefficient matrix for this system of homogeneous equations, and the matrix is 1, 2, 1. For the second column it is 2, 1. Just write the coefficients of beta for the second column. Just write the coefficients for the gamma for the third column. Now calculate the determinant of A. Let's check whether it is coming out to be 0 or non-zero, because for linearly independent I always need my determinant to be non-zero. So on solving this, I get determinant to be equal to -9, which is non-zero. Oh wow, very good. Which means this system 1 has a trivial solution, and trivial solution means all the scalars are 0. And if all the scalars are 0, which means all these vectors are linearly independent, and my work is over. So the system 1 has only trivial solution, thus alpha equal to beta equal to gamma equal to 0. And all these vectors are linearly independent. Sure shot method. Second, I have to show that every element of the given vector space is a linear combination of the given vectors. So let me take one element from R3. I have take x, y, z. I have to prove that this x, y, z is a linear combination of these vectors. 1, 2, 1 plus beta times 2, 1, 0 plus gamma times 1 minus 1, 2. And I have to solve the values of alpha, beta, gamma in terms of x, y, z, right? Okay, from here what I get? Alpha plus 2 beta plus gamma. And then 2 alpha plus beta minus gamma, and then alpha plus 2 gamma. Fine. So this is x, y, z. Then I have now three equations. This x is equal to alpha plus 2 beta plus gamma. Right? Let me mark this as 3. And then my y is equal to alpha plus beta minus gamma, marking this as 4. And then z is equal to alpha plus 2 gamma. Let me mark this as 5. Now first, what I have done is, I have multiplied 4 by -2 and adding in 3. So this is 4. Just multiply this with -2. I get -4 alpha, and adding to this third equation. So -4 alpha plus alpha gives me -3 alpha. And then -2 beta plus 2 beta will cancel each other. And -2 into minus gamma will be 2 gamma. And adding with this in 3, I get 3 gamma, right? So multiply 4 by -2 and adding in 3. What I get? I get -3 alpha plus 3 gamma equal to x minus 2y. Mark this as 6. And then what I have done is multiply 5 by 3 and add in this 6. Multiply 5 by 3 and adding in 6. Okay. So here, if I multiply this with 3, I get 3z equal to 3 alpha plus 6 gamma. And this 3 alpha will be cancelled out with this -3 alpha. That is why I have multiplied 5 by 3 and add in 6. So I get from here 9 gamma is equal to x minus 2y plus 3z. And from here I get the value of gamma to be as 1 over 9 x minus 2y plus 3z. wait, this is 3z. Okay, so I get my value of gamma, right? And what is alpha? Alpha is z minus 2 gamma from 5. So alpha from 5, we get alpha is z minus 2 gamma. So I know the value for gamma. So I write here, I put the value of gamma over here. So this is taking 1 by 9. So as minus 2 by 9, x minus 2y plus 3z. If you solve this, you will get your alpha to be equal to 1 over 9 minus 2x plus 4y plus 3z. Now remaining, I need the value of beta. I know alpha, I know gamma. From here, I can solve beta, right? Okay, let me take this for beta. I know alpha, I know the value of gamma. I will get now value of beta. Place beta here and take all these things to the left hand side. So from 4 we get beta to be as y plus gamma minus 2 alpha. Now what is the value of gamma? I am writing here 1 over 9 x minus 2y plus 3z minus 2 times alpha is okay, 1 by 9, it's minus 2 by 9 then, minus 2x plus 4y plus 3z. If you solve this, you will get your beta to be 1 over 9, 5x minus y minus 3z. Now substituting the values of alpha, beta, gamma into, we get, substitute this value here, we get xyz to be equal to 1 over 9. I'm substituting the value of alpha first, minus 2x plus 4y plus 3z with 1, 2, 1. And then 1 by 9, 5x minus y minus 3z for 2, 1, 0. And then 1 by 9, x minus 2y plus 3z for 1, negative 1 and 2. So now xyz is a linear combinations of 1, 2, 1, 2, 1, 0, 1 minus 1, 2. We get all our values of alpha, beta, gamma in terms of xyz. Now I can say that xyz is a linear combinations of 1, 2, 1, 2, 1, 0, 1 minus 1, 2. If you solve this, you will get your xyz back. When you solve this, you will get your xyz back. This should happen, okay? So now xyz is a linear combinations of this, but xyz was arbitrary, which means every element of R3 is a linear combinations of every element of R3 is a linear combinations of given vectors, that is 1, 2, 1, 2, 1, 0, 1 minus 1, 2, which implies thus 1, 2, 1, 2, 1, 0, 1, negative 1, 2 is a basis for R3. We have proved these vectors to be linearly independent, and we have also proved that these forms the linear combinations. These forms the generators of R3, or every element of R3 is a linear combinations of these vectors, which means these vectors forms the basis for R3. This is how we do the examples. We do the exercises. Alright guys, we meet in the next video. God bless you all. Have a very nice day.